Okay, hi algebra students. We're going to look at solving exponential equations today. So I'm going to share my screen and you can see the presentation. So to start, we have a warm up. You're going to want a piece of paper and just try these. The first one is what we've been working on the last few days. The second one kind of leads into what we're doing today. So pause the video and try them and then we'll come back. Okay, welcome back. Let's see how you did. So in this first one, let me grab my pen here. Come on, pen. Oh. All right, this first one, we look inside the parentheses. We have a fraction, but we have a fraction that is greater than 1. 4/3 is bigger than 1, right? It's 1 1/3, if you write it as a mixed number. So that would be exponential growth. So it is greater than 1. All right, on the second part, you're asked to write each of the following numbers as a power of 2. So I've got 32. So in other words, I have to have a base of 2. So let's see, I'm just going to start. So there's 2. If I do 2 times 2, I'm at 4. 2 times 2 times 2, 4 times 2 is 8. If I throw in another 2, let's say I have 2 times 2 is 4 times 2 is 8 times 2 is 16. Looks like I need one more 2 to get to 32. So 32 is 2 to the 1, 2, 3, 4, 5th power. All right, this time I have this 8. All right, we talked about this. We have 2 times 2 is 4 times 2 is 8. So we know it's 2 to the 3rd. But if you remember, in order for a power to end up in the denominator, that would be a negative exponent. So this is like 1 over 2 to the 3rd power. Or you could also write that as 2 to the negative 3. Remember, to change a negative exponent, we write it as its reciprocal. All right, let's look at negative 16. So let's go back to our 2's here. 2 times 2 is 4, times 2 is 8, times 2 is 16. So it looks like we need 2 to the 4th. And since there's a negative in front, I'm going to put a negative in front of the base of 2. 1/2. Again, remember, that can be written as that's reciprocal. So this is 2 to the negative 1. Would be 1/2. All right, let's look at our next part. We've got some vocabulary to write down on page 190 in your journal. So we have the definition of exponential equation and the property of equality for exponential equations. So go ahead, pause the video and copy those down into your journal. All right, an exponential equation is an equation in which variable expressions occur as exponents. So today you're going to see things where it's not just numbers as the exponent, it could be some variable expressions. So you're going to see some x's up there and stuff. Property of equality for exponential equations: 2 powers with the same positive base b are equal if and only if their exponents are equal. And I gave an example there. So if I have 2 to the x is equal to 2 to the 5th, that means that this x has to equal 5, okay, in order for this to be a true statement. So we're going to put that to use by solving some exponential equations. This is extra practice on page 191 in your journal. So if I look at these problems, I'm going to grab a pen here. Change color. Let's go with, do I have just regular purple? All right, we're going magenta. All right, so we have the same base of 3. In order for these two things to be equal, in order for both sides to be equal, that means that these exponents also have to be equal. So that means that 4x has to equal 12. So I'm going to solve that equation. I divide both sides by 4, and I get that the x would have to be equal to 3. And that makes sense. If I plug a 3 in here, 4 times 3 is 12. 3 to the 12th certainly equals 3 to the 12th. All right, here's another one. We have a base of 8. So that means that these exponents must be equal to each other. So I write down x plus 5 equals 20. I'm going to solve for x, subtract 5 from both sides. And I get x is equal to 20 minus 5 is 15. All right, this time base is 6. My exponent, I have 4x minus 5. must be equal to 2x. So I'm going to write that down and solve it. I'm going to get my x's together on the same side, so I'm going to subtract 4x here. So that gives me -5 is equal to 2x minus 4x is -2x. Divide both sides by -2. And I get x is equal to, let's see, a negative divided by a negative is a positive, so I can either write this as 5/2, or for those of you who like decimals, this would be 2.5. All right, let's look at this one. This time we have a base of 5. Our exponents are 6x minus 3 and -3 plus 4x. So I'm going to set the exponents equal to each other since they have the same base, and I'm going to solve for x. So I'm going to get my x's together on the left by subtracting 4x from both sides. So 6x minus 4x is 2x, minus 3 equals -3. Add 3 to both sides. And I get 2x is equal to, and it doesn't look like a 3, but it is. And 3 plus 3 is 6. Divide both sides by 2. And I get that x is equal to 3. And remember, you can always check. So let's see. 6 times 3 is 18, minus 3 would be 15. And let's see if we get 15 for the other one. Let's see. 4 times 3 is 12. -3 plus 12. Did we miss a sign here? Because that doesn't look like it's coming out right. Oh, yeah, this is a 0. Silly me. -3 plus 3 should have been 0. Good thing I checked. So this should be 0. All right, now let's try it. 6 times 0, 0 minus 3 would leave us with a -3. And over here, 4 times 0, 0, we'd be left with -3. Okay, so it works. So good thing I checked that one. All right, let's look at our next slide. This time it says, what if the bases aren't the same? Try rewriting them. You're going to add this to your notes on page 190. So if you look on your journal, you'll see some space. On page 190, write down example 1, and then we're going to go through these. So go ahead and pause the video and copy these down into your journal. All right, these problems relate back to the warm-up we were doing. So we'd like the exponents to be equal so we can solve for this x, but this one doesn't have an exponent. So I need to try to rewrite 8 with a base of 2. So if you think back to what you did in the warm-up, to write 8 with a base of 2, that would be 2 times 2 times 2, right? 2 times 2 is 4 times 2 is 8. So that right side, I can rewrite 8 as 2 to the 3rd power. Now I have the same base. I can set the exponents equal to each other, and I'd get x equals 3. All right, let's look at this one. We have a 3 here. This is close to a 3, but it's a 1/3. So I'm going to rewrite 1/3 as 3 to the -1. Remember, we can rewrite those with negative exponents by using the reciprocal. Now I have the same base on both sides of the equal sign. So I can set the exponents equal to each other. I'm going to set -1 equal to x plus 4 and solve for x. So my x is already on the right, so I'm going to subtract 4 from both sides. That gives me -5 equals x. All right, and if you plug that in, you'll see -5 plus 4 is -1. If I plug that in up here, -5 plus 4 is -1, and this is 3 to the -1, so it works. All right, so we have some more extra practice. Solve each equation and check your work. All right, so let's look at number 9. If I look at the right, I've got a base of 6. So I want to know, can I write 36? Oops, let's go back. Can I write 36 with a base of 6? Let's see. 36, we have 6 times 6 is certainly equal to 36. All right, so this number right here is 6 to the 2nd power. All right, but I have these exponents up here. So I'm going to put a parentheses around this. And I'm going to put my 6x minus 1. So this time it's a little more complicated. We're going to use our power of a power rule for exponents. All right, so I turned 36 into 6 to the second. But now, since I have an exponent on the outside and one on the inside, I need to multiply those exponents. So I'm going to multiply 2 times 6x and 2 times -1. I'm going to use the distributive property. So this side is going to turn into 6 to the 2 times 6x would be 12x. And 2 times -1 is -2 equals 6 to the 5x. All right, now I have the same base. I can set these exponents equal to each other. So I write down 12x minus 2 equals 5x. I'm going to solve for x. I'm going to subtract 12x from both sides. And I get -2 is equal to 5 minus 12 is -7. Divide both sides by -7. And I get that x is equal to negative divided by negative is a positive 2/7. So don't panic if you're getting fractions on these. It's okay. It's going to come out that way sometimes. All right, let's try another one like this. On number 10, this time we have a base of 9. And can I write 81 with a base of 9? Sure. If you remember, 9 times 9 is 81. So I'm going to leave the left side alone. And I'm going to write the right side as, well, 81 is 9 to the second power right here. 9 times 9 is 81. But I'm going to put it in a parentheses because I don't want to lose this exponent that's on the outside. So now I have my 9 to the x minus 4 equals 9 to the 2 times 3x would be 6x. Remember the power rule, if one's on the inside, one's on the outside, you multiply. Now I have the same base. I can set those exponents equal to each other. I'm going to subtract x here. And I get -4 is equal to 6x minus x is 5x. Divide both sides by 5. And I get x is equal to a -4/5. All right. So the next side is your assignment, but I don't think we have all this. This is your assignment for today. Actually, it says the puzzle, it says 6-5A, but I think we're doing I think it's a puzzle time worksheet. I'll post it on Schoology with the correct assignment. In the meantime, if you have any questions, or send me an email. Good luck.